Hi folks, this problem is about what minimum velocity an object or an automobile has to be going on a banked curve to maintain its position on that bank without any friction involved. Now, the reason that a lot of racetracks and bicycling tracks and things like that have a curve on them is so that some of the force of friction is not the only thing that is providing the centripetal force. It's also going to be some of the normal force that's also going to be providing the centripetal force. Now, we don't have to go back to bare bones and sum those forces because there's a handy little equation for minimum velocity on a banked curve. The tangent of the angle of the curve, is equal to the minimum velocity to go without any friction divided by the radius of the curve times the acceleration of gravity. Now we're talking about the Daytona 500 track, which is down in Daytona, Florida. It's a 2.5-mile tri-oval track. It's got 1, 2, 3 little sideways parts that are actually, we have some sort of a bank on it. And we're interested on the two far ends. Each one of these has a 31-degree angle. The radius of each one of these is about a third of a kilometer. It's quite big. So the radius is 316 meters. And I want to know what minimum speed a car has to be going so it just stays on that bank curve. If it's going too slow, it's going to fall down the bank. If it's going too fast, it's going to crawl up the bank. So here goes nothing. Here's my equation. I want to solve for speed, so it's going to be my velocity. So this is going to be the tangent of theta times radius times acceleration of gravity, and then to go from v squared to v, I'm going to take the square root of that. So the minimum velocity is going to be the square root of the tangent of 31 degrees. Radius of Daytona is 316 meters. Now that's just the curved portion. And the acceleration of gravity, 9.8 meters per second squared. And when I do that, I get a velocity of 43.1 meters per second. Now, growing up in the United States, that number doesn't mean a lot to me, so let's translate that into miles per hour so I can kind of see if it makes sense. I want to get rid of meters, go to miles. There are 1609 meters in a mile. Get rid of seconds, go to hours, and there are 3,600 seconds in an hour. When I do that, that is about 96.5, about 100 miles an hour. So you're going to go kind of speedy just to stay at your position on the track.